Hi guys, so I wanted to make a little YouTube video that you could scan on your worksheet if you needed help while we were working on our new topic of molar masses. So molar mass is the weight in grams of 1 mole, which is a lot. So 1 mole, it's kind of like our chemist's dozen. It's actually 6.02 times 10 to the 23rd of something. So in this case, it's going to be atoms, but it could be a mole of students, a mole of eggs, a mole of marbles. So in fact, you'll see in the YouTube video, a mole of marbles actually would cover the earth 3 miles deep all the way around. It's a huge number. That's 6 with 23 zeros after it. So 1 mole is, in a chemist case, we're looking at 1 mole is 6.02 times 10 to the 23rd atoms or molecules. So we're going to be calculating what's called molar mass. And to do that, we're going to use the molar mass on the periodic table for each element in a formula. So let's take a look at that. Real simple. So if I have a compound like H2, so hydrogen gas, if I wanted to know how much 1 mole of this weighed, so how much does 6.02 times 10 to the 23rd molecules of this weigh, I would take the mass of hydrogen on the periodic table, which is 1, and then times it by how many. So in this case, I have 2 hydrogens in this formula. So the molar mass would just be 2 grams per mole. So for every mole, so for 6.02 times 10 to the 23rd molecules of hydrogen gas, it would weigh 2 grams. Now you can actually, this is totally tangible. So if we had NaCl, we wanted to find out how much table salt, which is NaCl, we would have to weigh out to get 6.02 times 10 to the 23rd molecules of that, we'd add up the formulas. So sodium, let's see, I think sodium, I'll look that up. I want to say it's 23. So 23 grams, we have 1 sodium atom in this compound, plus our chlorine, which we only have 1 of, and that's actually 35. Grams. So if we added it up, we would get 58 grams per mole. Now we can actually take salt and measure out on our balances 58 grams, right? It's about a palmful of salt. It's about 58 grams. So it's not a lot. That's how small atoms are when you compare it to marbles covering the earth 3 miles deep. But this is how we do our molar mass. I'll show you just one or two more. So let's say we had magnesium chloride, which is MgCl2. You're going to take the molar mass of 1 magnesium. So we have 1 times we have 1 times 24, which is what it says on the periodic table, is the atomic mass for magnesium. So that gives us 24. And then we have chlorines, and if we look at the subscript, we have 2. So we're going to do 2 times 35.5. which is the molar mass of chlorine. That's going to give us 71. Now if we add these two numbers up, we get 95 grams. So if we had magnesium chloride and we weighed out 95 grams, that would be 6.02 times 10 to the 23rd atoms. So this is how we go through the process of getting molar mass. And it works for any compound. Now I'll do one more. Let's do calcium hydroxide. Because the parentheses make it a little tricky. So now we have three components. We have calcium, oxygen, and hydrogen. Our calcium we have as 40, so we have 1 times 40 grams. That's what the atomic mass is. So that's going to give us 40. We have oxygen. Now this 2 outside the parentheses gets multiplied to both atoms. So we have 2 oxygen, and there 16 is the molar mass, sorry, the atomic mass, and that multiplies to 32. And then our hydrogens, we have 2 of those at 1, so that gives us 2. If we add them all up, we get 74, and that's going to be grams per mole. So if I weighed out 74 grams of calcium hydroxide, I would get 6.02 times 10 to the 23rd moles. So this is the molar mass for calcium hydroxide. So hopefully this helps. It's kind of like a puzzle. It's just a lot of multiplying and adding. Anyways, good luck, and let me know if you got questions.